Hey everyone. I was just lying around and I thought, why not I just make a video about .NET and Unity games, and specifically about reverse engineering them. So, in this video, we will be trying to tackle some basics about reverse engineering .NET applications, specifically written in C Sharp, and we will be trying to tackle also a Unity game that was created by my friend. It's actually a demo. We will be trying to see in the second part of the video. But in the first video, we will be trying to reverse engineer a portal of plugin that I have created. So without further ado, let's not waste too much time and try to see what this portal is doing exactly. So if we just open the portal, we see that please be sure a sound file exists at the specified location. So it's just some random error message. So as you can see, we have a username and we have a password. Now, what if we give, for example, I don't know, Mike, and we give the password, for example, 123. Now, this equation is a piece of cake to the reader. Keep trying. So just a backstory behind this challenge. It's actually a challenge that I have created for a local CDF in my university. So it's just a simple, basic challenge for people who do not .NET, just to let them learn about reverse engineering .NET. So it's not obfuscated, nothing, nothing just to deal with. So it's a basic challenge. Yeah. So the first thing that we have to understand about .NET, guys, is that .NET is a really interesting thing, because actually a lot of softwares that we are dealing with in Windows specifically are written in .NET. Um, for example, a lot of softwares I have been using my whole life were written in .NET. That's why I thought reverse engineering .NET is quite cool. So why not just we make a video about .NET and explain at least the basics of how you can reverse engineer them. Actually, when you try, for example, to reverse engineer a I don't know, a real world software that was written in .NET, it won't be that easy, because I suppose the company should be implementing some security layers to prevent the reverse engineer from just doing his own thing. Yeah. So the first thing I suppose that we should do when we try to reverse engineer any kind of thing is just to at least read about the .NET. So when we type, for example, .NET reverse engineering, I suppose we will be having a document from the UWASP. This document actually I have read few like years ago, but it's a really interesting document because it explains the way that the .NET was reverse engineered, which is really interesting. But from the perspective of someone who is trying to just solve the challenge, we can just type, for example, tools. For example, let's try to find out if there are any kind of tools that are available for us that we can use. So if we try to see, we have disassemblers, we have debuggers, we have process explorer, and we have file scanners, etc., etc. So these obfuscators are really interesting because they can obfuscate the code for the one who is trying to reverse engineer, which will make the process harder for them. So let's not dive too much about obfuscators, since I think obfuscators deserve a video. Yeah. So let's see disassembler. So we have dnspy, which is a pretty famous one and that we will be using in this video just to reverse engineer this .NET binary, and we will be also using it for the game that we will be trying to reverse engineer using Unity. Um, we have also SIE. We have the .NET reflector. So actually, it's a let's say a paid software. We have ILSpy too. I've been actually very familiar with the DNSpy and with the ILSpy. but I have never used .NET Reflector and the SIE. I've also used the Windows debugger, and I'm quite familiar also with the debugger of the DNSpy. Yeah, so in this video we'll be using DNSpy. You can just check them out if you want all the kind of software that are available for you that can help you reverse engineer .NET. So yeah, so I have already downloaded DNSpy in my computer, and the first step is to just before just diving, we can just try to see the format of the portal that we are dealing with. So it's a PE, which is a portable executable file for Windows with a 32-bit architecture. So this is the processor, which is Mono. We have also the Mono.NET assembly. And yeah, so let's just try to open DNSpy. So this is DNSpy for the 64-bit. So we need the DNSpy for the 32-bit since the binary is 32-bit. So I have downloaded that, I suppose. DNSpy 32-bit. I suppose this is the one. Yeah. So this is the 32-bit DNSpy. Now what we need to do is we need to load the binary into DNSpy. So to load the binary, we can just drag and drop it. Yeah, after just doing a simple drag and drop, we see that the binary is loaded into DNSpy. Now, what's really interesting is that we can see the different offsets of the PE file. I've never explained for you what the PE file format is since I have tried to make a video about the ELF, but I didn't make a video for the PE. Actually, I didn't have the chance to explain them in a video. For now, let's just skip the part where we have to explain what the PE headers are. We can just see them in another video, maybe in the future. What else do we have? So this is the type references and the references and basically the resources where we see, for example, images and kind of stuff, for example, where the portal is doing, for example, this image and um, the whole image behind the background. We can see all of them in their sources. Now, if we go back, let's skip this part of Modable, and we see in this place that we have the program main. And as you can see, the DNSY have already decompiled for us um, the logic behind the Quijin, or the, let's say, the gene. Yeah. The gene is much more better than the equation. I don't know even why I have just named it equation, but yeah, that's it. Um so this is, I suppose, the class program that contains actually the main program in C sharp. So yeah, so it's trying to, so this play simple sound is actually trying to um, create an object of a sound player with the path of dot slash music dot wave, which means that we should provide for it a file of that of dot wave, and it's gonna be playing that music for us. So I suppose if I try to give it, for example, or try to download a music file with a dot wave extension and throw it in the same directory as the binary portal, I suppose the music should be playing. Otherwise, so it's in a try catch block, so we try to do it. Otherwise, we catch an exception. If an exception happened, for example, in our case, when we try to open the portal, I suppose we actually got a message which is please be sure a sound file exists at the specified location. So this is basically the message. This is the EX message actually that was shown in the message box. So this is the message box, and yeah, I suppose after that it will be just opening the portal for us despite not having the music loaded. Now, what's really interesting now, if we see the main, we see that he's doing some just basic C Sharp development while working with Windows, which will be enabling visual styles. We can just ignore all of that, and the program .play simple sound that will play the simple sound. So as we can see, he's not checking if an error was thrown um, before or let's just say after the play simple sound. So that's why, despite the exception that happened, we will call the application.run new form1. Now, new form1 is the new class. Now we can check the new form1 too, or we can just check the form1 class. So, as we can see, the form1 class is having a lot of stuff inside of it. We will try to just reverse engineer them statically. And before just reverse engineering them statically, we can just do that dynamically by just trying to set a breakpoints at some, I don't know, at some lines in the code and then try to run it as we have done, um, as we were just like doing in the previous videos. Despite now that we are trying to do it using the dnSpy, not the GDB. Yeah. So we have the win, we have the fail. So these are two like pretty basic functions that will print for us the win function or the win message and a fail message. And as we can see, this is the message that we've been getting since we have tried the portal. For example, the equation is a piece of cake to the reader. Keep trying. Yeah. So this is just keep trying. Yeah. So we have also some kind of function that is called gen. So I suppose that will be generating something. Since we have the names of the functions that will help us reverse engineer them, um, just using the names. So using the names, or actually the name of the function, can help the reverse engineer try to understand what the developer was trying to do. So I suppose the gen is just trying to generate some numbers. What else do we have? So we have the question. I suppose it will be getting a username and a password. And then let's just try to skip all of that code. And then it will be just trying to set the password as a text that is already generated using this block. Yeah, we will get back to this. Now we have the check that will be checking if the user password equals to the original password. Now, if you go into the bottoms one click, that means that this is a bottom. So once we click that bottom, I suppose he will be trying to call all this code, or he will be just executing this code. So text one is text box one, and text two is text box two. I suppose this is the text one box, and this is the text two box. And he is calling form1.begin with the text and a reference to an original password, which means that he is passing the original password as a reference, which means that the original password can be changed. Actually, I'm not saying that it will be changed, but can be changed since we are passing it as a reference. Now we have the flag, which is equals to text, which is equal to um, which is equals to an empty string, which means this is actually a Boolean operation that will return either true or false, which means that if the text is empty, then we will we will print username is empty. We do the same thing with the text too. Um, if it is empty, then we will print just a message password is empty. Now, otherwise, if the two of them are filled, we just call the check with the text to with the original password. The original password is supposed to be generated using um, this question method. So if flag 3, then we print the win, otherwise we print the fail. Now, the first thing that came into my mind, guys, is just to try to breakpoint at this line and try to see, for example, the original password for Mike before checking it or before comparing it with the generated um, before checking it with the generated password. So to do that, for example, we can just breakpoint in here. So this is the way to set a breakpoint, and you can just start the process. Before we start the process, I need to close this one. We start now e process, and as you can see, running, which means that the debugger is running. Now, for example, if I call Mike, and for example, random, just random password, and once we hit the breakpoint, as you can see, this is the next state. This is the next statement that will be executed. And as you can see, this is the original password, and this is the password that we have entered, and this is the username. So I suppose if he is not randomizing each time the password for the username, then we can just use this password for this username. And actually, we have cracked his portal. Um, so if we try, for example, now to stop the process and try to see if he is randomizing the password or not, we can just try to again start the process. For example, we do Mike, and we again print or give some random password, and then we log in again. And as we can see, it is the same password. So that means that he is generating the same password for each username that is passed to the portal, which is a weakness. Actually, it's actually a vulnerability, not just a weakness, which means that this software is very weak. Now, if we take this password, for example, and try to use it as the password for Mike, let's just try now to do it without setting the breakpoint. For example, Mike. Good job, you can validate with this username. So I suppose until this moment we have just cracked the software. Now, whenever I want, for example, to add, for example, my friend or I don't know, my brother into this portal, all what I have to do is just tell him to give me his username, and then I will set a breakpoint and then generate, actually try to find out what is the generated password for example, my friend username, and then give him back the username and the password generated and tell him that he can now log in into the portal because we have break up the portal. Now, this is basically how you can just set a breakpoint into the code. Now, what's really interesting is that we can, instead of just setting the breakpoint all over and over again, we can just try to reverse engineer the code statically. What does that mean? We can just see how the code, see how the password is generated and mimic the generation of the password the same as he is doing. And then we try to create another, let's say, software that will be generating password based on the username that was given to that software. Let's just call it password generator or I don't know, something like that. Um, so to do that, it's pretty easy. All what you have to do is just take the equation code as it is and take the generation method as it is and combine them together in a code that will be taking the username, um, sorry, and then it will be generating for us the password. Now, I have done that actually um, in an online C# compiler. So I have included system and system collection for the stock because there is a stack, I suppose, in the code. Let's just go back a little. Yeah, there is a stack. Okay, I think it's time just to explain for you the code before just trying to mimic it as it is. Why not just we try to understand it? So I suppose the question will be getting the username and the password. So if we take a look, we have length. We are creating a variable called length that will be taking the username length, and we are creating a data structure stack they will be creating a stack for us. And then we are iterating through We are iterating through the username, and each time we are pushing a character of the username into the stack. Now, once we have finished that, I suppose once you see this code, you will be trying to think as if the username is actually reversed in the stack. What does that mean? Actually, that means that once we try to push something into the stack, we always find at the top of the stack the last element that was pushed. That means that when we try to see the stack in front of us, it will be having the username in a reversed order. So, for example, just for the sake, just trying to see what this will be happening. So, for example, let's just take the username equals to, for example, Mike. Now, if we do stack dot push, for example, the character, let's say M, and then we do that um, differently with the different characters of the username, we see that we will be having something like that. Now, if we try to see what the stack will be having, so it will be having um, M, and then it will be having, let's say, always that the first element will be the top, and then it will be having like that. Yeah. We have the K E. I'm sorry, K E, and this is M M. Yeah. This will also be having K E K E M, which means it it's just Mike in the reversed order. So this is basically how the stack will be having. So this block of code is going just to reverse the username for us. Now we also have a text that was initialized with an empty string. We have an array that was also initialized, an array of integers that was initialized with a size of 512, and then we are calling the generator, I suppose, which is the gen method. We are passing 256 and the reference to the array. So that means that this this gen method will be trying to change the array, which means that it will be setting the values of the array. So if we take a look at the gen, we have n and we have an array, which is a reference. So it will be iterating from 0 to 256. It will be setting the array of I to 1, which means that it will be initializing all the values of the array to 1, and then it will be setting the array of 0 to 0 and array of 1 to 0, and then it will be initializing a variable called num to 2, and then while num by num equals inferiors or equal to n, then we will be doing a flag and another boolean conversion. It will be comparing array of num with a 1. So it means if the array of num is equals to 1, then we will be doing this, and then we'll be incrementing the num. So let's suppose now we are at the iteration um, 2, and since array of 2 is equals to 1, that means that this condition will be fulfilled and we will get into this block of code. So it will be going from int of g equals to 2 by 2, and while 2 is inferior or equal to 256, um, the g will be plus or equal, let's say plus equal, which means we will be adding to g2. So just by looking at this code, guys, I don't know if you have an idea about this algorithm, but this is actually the sieve algorithm. You can just Google it if you want and read a little about it. So sieve algorithm. So sieve algorithm is quite an interesting algorithm that was used to just find all the prime numbers less than or equal to a given integer n. So just to look back, so this is just a simple sieve algorithm that will be generating um, that will be finding and generating the prime numbers. So that means when we try to see just the final array that will be generated using this function, it will be setting 1 at the index of the prime numbers, and it will be setting 0 to the index of the numbers that are not prime numbers. It's pretty easy. You can just see that if you want. If you are stuck and if you don't know what the sieve algorithm is, you can just see, for example, I don't know. For example, we can just try to run the code and see, or just try to figure out a pattern between um, between the elements. For example, a relation. For example, just by looking at the code, you will see that the indexes that are prime are actually 1, and the indexes that are not prime are actually 0. So this is basically what the Jan is doing. No, I think now we should just go back. So since we have understood what this form Jan 256 is doing, now I suppose the reference array or the array will be containing um, ones and zeros. And depending on the index, we can understand or we can know what is the value of that index in the array. Yeah. So now while the stack dot count different to 0, what does that mean? That means while the stack size is not 0, it means the stack is not 0, we will be trying to create a variable c that will be stack.pop. So stack.pop is the top of the stack, which means that we will be getting the element at the top of the stack uh, into C. And then we will be trying to get the num, which is the integer of C, which is actually the ASCII of that character, into the num. And then we will be trying to iterate from 0 to 256, 56, which is the size of the array. We will be doing flag equals to array of g equals to 1. So that means if the array of g equals to 1, means if the index at that position is prime, then we will be doing num XORed with that index. So that means that once we are at a prime index, we should be XORing that index with the number, which was already initialized as the ASCII of the character that was already pooped up from the stack. And if you remember and just go back, the stack already is having the characters of the username just in the reversed order. So once this block is done, I suppose the text or the generated password should be we will be adding number minus 95, which is just a character that will be pointing to the number, to the generated number that was already XORed with all the prime indexes from 0 to 256, and then we will be subtracting from that number 95, and then we will be converting that ASCII into its actual character. Now once we do that, we append it to the password. So this is basically how the password is generated. It's not that hard to understand. Nothing about cryptography is involved, just some basic abstractions and some XOR. So it's pretty easy. Now, once we have understood what this code is doing, we don't have to put too much effort. All what we have to do is just combine the gen and combine the code that was generating. And all what we have to do, for example, if we want to generate a password for Chris, we can do just run. And this is the password for Chris. Now, if we go back to the portal and we put, for example, Chris, this is what the password of Chris is. So my friend Chris, for example, can now log in into this portal without having any kind of issues. So yes, next game that we'll be having now, I suppose we will be trying to patch it down. So for now, let's just ignore the fact that I tried to patch the portal, and let's just play the game. So the game you can just find the link of the game in the comments below, I suppose, or the description. I'm sorry. and it's actually a game that was developed by my friend. So I have asked him if I can try to showcase the way we can cheat into this game um, for you, and he actually accepted that. So yeah, so it's actually a demo of a game. So it's a demo about let's just try to play a little for you, just to see what this game is about. So it's a puzzle game. As you can see, where we try to gather items and stuff, I suppose. So I suppose you should be just trying to play the game, not cheat on it. But I'm just trying to cheat on it. So here's a book. You can just play and read the document. It's actually an interesting puzzle game. You can just play it. Now, what's really interesting about this game is that I found actually this suitcase that needs a code in order to open this suitcase. So to do that, I actually when you try, for example, to type in a code, it's saying wrong code. Actually, to understand what this code is, or just to figure out what the code is, you need to play the game and find out what the code is. But I was just too lazy to find out what the code is, and I thought maybe it's time to just make a cheat for this game. So to do that, I've actually just tried to find the assembly of the program, or the, let's say, the game, and try to change it the way I want, or just to find, or just try to figure out what the code is in the file of the game itself. So if you go into Solitude demo data, and then we go into manage it, and then we go into assembly C sharp DLL. This is actually the file or the dynamic library that has um, the logic of the game, let's just say. So if you try to open it using dnspy, let's just close this collision. So yeah, if we throw this in here, and try, for example, now to open this assembly C sharp, and let's just now use defined. So if we try to use, for example, we are searching for code, for example, in the selected selected file, yeah, in the assembly C sharp DL, we can see that there is a method called check code that has all this logic. So as you can see, this is the wrong code that is in the game, and this is the logic behind the code. So if the code is equals to this dot write code, then we will be having write code hammer was added to your item. So I suppose there's a hammer inside of the suitcase. um, Otherwise it will be printing for us wrong code. So there are two kinds of codes in the game of my friend. So we have a code for the suitcase and we have a code for the lock drawer. And if we try to see, for example, the right code of the suitcase, if we double click on it, we see that it's a private it's a private attribute in the class, so we cannot see the value. Now, the first thing that came on my mind to try to get the hammer is to change this right code into a one that I already knew. So to do that, we do the same thing as before. We try to go into that. So we try, for example, to the first thing that we do is we do need to correct the syntax, let's just say the syntax issues, because sometimes the dnspy will be adding some stuff to you. You need to get that right, and we need to change that. For example, let's just try it into 1 2 3 4, for example, just for values. That's a simple code. And then we compile this code, and as we can see, the code have changed. Now, in the previous portal, there was an issue that happened with the portal because it crashed, and I don't have time to just find out just why the portal has crashed. But I suppose now once you see this, you should be able just to understand this. So now, since we have made a change in this module, we need to save it. So to save the module, we need to go into this place, which is this, and we need also to make a backup of the original assembly C sharp. Why? Because sometimes you wanna just go back and use um, your old logic. So this is actually just like modding the game and creating a cheat for it. So now if we try to do yes, okay, I suppose now the DLL has been loaded into the game, or the new C sharp assembly has been have been loaded. Now if we try to open up the game again, and we go back into the suitcase, I suppose one, two, three, four. As you can see, right code, a hammer was added into your items. So now, if we try to see the items, we see a hammer. Yeah, so this is basically how you try to cheat on Unity games. Actually, this Unity game is not secured. There is no obfuscation on the code. I can just do whatever I want. I can read the code the way I want to. I've been already just telling that to my friend, and he is really interested in securing his game. So I suppose you two should be trying to secure your game from people like you, from people like me who are trying to reverse engineer a game. So yes, I hope you have learned something new. And don't forget to subscribe, I suppose. Don't forget to follow me on Twitter too. And yes, there is a Discord that I have created. You can just join that Discord too if you want. Yeah, that's it. Goodbye.